Hallo, Test. Test. Yeah, it seems like that we are live. Yes, okay. So we do a little intro here. Hello and welcome. And in this stream, I want to do a little project, a Python side project. During me doing a break from my usual work, and the side project is a little Python program which I call Snake. This is the GitHub repo for that, which you can find on github.com Python user/snake. And this is a little multiplayer game written with Python and the TDL package and the Twitch observer package, and can be directly played from within the Twitch chats. So if you want to follow along, you can look at the repo, or you can send me and connect to me via Twitter at Python user. Yes, so hi Phil. So we can do something like so you can have a look at here, the repo, or send me a message on Twitter. All right. So this is how that looks like. So this is kind of a debug view of some players that have joined with their snakes in this little window here and trying to beat each other's asses off. And we maybe run the game just for you folks to enjoy and to show that off. So it's just Python, just a pure Python script. So this is the game. Hopefully this will load it up. And yeah, so this is now the game window, and by typing join, one can actually join to the game and then walk around with this little snake. So how to do that properly? Yeah, it's a little bit tricky now with this crappy one screen setup I got here, because I'm kind of remotely working on my laptop. So I can type in join, and now you can see here this is my name here, I'm player, and this is my snake, and I can move up or right, down. And once again left, and then if I crash into the border here, I lose my segments, my body segments, and then eventually I die. So this is the game for now. So let's make that bigger in here. Cool. So this is the snake thing here. Yes, and Xarsiu left after after a minute again. So, oh, this is not the usual Dark Souls stream, so I don't want to to attend that. No, this is today a pure programming stream I will do. So I want to have a balance between programming and gaming. And yeah, I hope the quality of the stream isn't that bad. Of course, this notebook is not as powerful as my desktop machine. Alright, so what to work on? So this is basically the current status. I got some issues here, which basically collects all the stuff which I could think of in 5 minutes to add to the game. So basically I want to add some collectibles, maybe have a different level layout, so just spawning some obstacles on the level, and also adding a blinking animation to the snakes when they get hit. No, so just visual stuff. And there is also a bug, which I call the player collision bug, which just means that those snakes cannot collide with themselves. Excuse me. So if I fire up the game once more, so Python game, and I do the setup here. It's so disgusting with one screen. It's just fiddling. Okay, so I type join. There's my snake. I do up and right and down, and I just go through myself, which is, if you recall the original Snake game, is also something that you will, an action that you will lose your life. So let's implement that. Alright, so I got it open here in Sublime already. So this is the project. And let's go into the scene. Here we got a game scene, which renders all the entities, so all the snakes and the level onto the screen. And yeah, we need the collision stuff, so that will be in snake, which is the actual snake player object. And this object has a draw method, so just to draw its content, so the head and the body segments to the screen. Then it has a handle event method to handle the chat events, and an update method which updates its state according to the events. So if you change the move direction, for example, then this update method will advance in the next game tick, advance the snake to that position using the move function. So, and yeah, the let's see. So we check for collisions actually 2 times. So in the handle events and in the update method, which is maybe not the smartest way to do it. But let's see. So this is kind of just the movement code. So we calculate the last movement direction to then say if we now want to make a move, if we are going upwards and the player wants to go downwards, then you would collide with yourself, just because the user made a bad input. And this is usually, well, this leads to frustrating gameplay, you know, because you can screw yourself up. So we make sure that you can't do that, and then your input is basically discarded and you just go up. Nevertheless, then we do some collision checks with the level, and if we collide with the level, then we push a collision event to the event stack. And maybe that is also where we could put this in. So we say if scene, game scene, current scene get tile type at position is not equal to none, then we basically have a wall, because the tile type does it live in level? Yes, so level. Yeah, so in level we define a class which is tile type, and this which currently only knows the two types none and wall. So these are the white hashtags, the sharps you can see. So and then we have the level, which is just the definition of this wall layout, which then the entities in the scene get drawn onto. So let's have a look at chat real quick. Alright, let's make that big again. So so we should do check for collision with level, and also we should do check for collision with self. Do we do an elif, and then basically scene.game scene current scene, yeah. So if we got no, we just could do an else. This is, I guess, the better way to do that. So we test here for if the tile type is not none. So if it's not a wall. Oh wait. Yeah, right. So if it's not none, that means it is a wall. Then we do the collision, and we get the entity, which is just the wall. So if there is no tile type, so this is else, right? Then we try to get the entity at that position. Maybe there's one. So we say entity to collide with equals scene.game scene.current scene dot get entity at position, and we put in the target position we want to move to. This is the entity to collide with. So this is a method we defined in scene, and this is that one, get entity at position, and it returns the entity on none at the given position. So we go through every entity, which is a snake. which is not very smart because we have to change it if we add collectibles, but for the time being this is sufficient. And then we check for the hats and the second positions, and if that is equal to the position we want to move to, so we want to return the entity add, then we return that entity, otherwise it returns none, which is just the default behavior of Python. If you have non-return statements stated for a method, it will return none. So we get that. So we get that entity at that position we want to move to. If entity to collide with is not none, so if there is an entity, then we will just push an event. So TDL event dot push. We do a collision event, and this takes in an owner and a target. And this means the owner is who triggered the collision, and the target is the object or entity that is the owner colliding with. So we have a collision event, we put in ourself and the entity to collide with, which are named target here. Maybe I do the same here. Targets. Oops. All right. So we push that. Yeah. But now we run into an issue with this code here. So previously I said if we are not colliding with the level, then we can move. But now I get another case here. Well, for lack of a better way to do that is just I define a bool here is colliding, set it to false, and then we can set that here if we have collided. Is colliding is equal to true, and then we move only if not is colliding, and then we do the movement code, which is pretty damn ugly. But I currently can't think of a better way to do that. So it's just create dirty. So let's start up the game and test that. So Python game. And we got an issue here, yeah, which is we don't have this construct anymore. Fire that up. Alright. I got too many windows open. This is the current one. Yeah, so that worked. This is the game window. I really hate this setup, this one screen setup. And we do a join. Yeah, and and it picks a random direction to random position to spawn the snakes, and then a random move direction in this spawn. Yeah, so the body segments get spawned out of the window. So this is definitely something to look at. So up, right, and down. Oh. Something happen? No. Right. Down. Left. Okay, I have two less segments here, so start it again. Join. Up, right, and down. Yes. And we move. Yeah, great. So now players can collide with themselves and actually use body parts. Oh, I guess I misspelled right. That is why it didn't work last time. Alright. So, git status. Yeah, and then also change the font to 24 times 24 characters instead of 32 by 32, because the game window was just too big for this little screen here. So I had to downscale that. Alright, so we can add game.py. No, actually not, because that is just this change here on that machine. So what we actually only have to do is add in the snake and say fixes. Let's over to the repo. Yes, so this is the player collision bug, and this is the number 3. So fixes number 3, and git push it up. Cool, and it got automatically closed. All right. So, so we're in the stream approximately 20 minutes. So what to work on next? Different level adds is something I want to do later on. The blinking animation or adding collectibles. So I guess the blinking animation is something to look into, because I want to implement 2 blinking animations that signal 2 things. So the first one is that you are getting hurt, so that someone bumped into you, or that you bumped into someone else, or in the wall, you know, that you are getting hurt. This should signal that. And also, if you got hurt, then you will enter a state of short immunity, where you kind of pass through everything if it's not a wall, you know. But if you hit a player, then you will get hurt and then be invincible for, I don't know, 2-3 turns, and this makes you kind of able to switch switch the direction to avoid further harm. So how to do that? I guess we have to create a new file. Which I will call animations. So in here we define an animation, which we will call blink animation. Animation that changes the color of a set of characters in a specific time interval. Like so. And so we need this set of characters. So those are the characters. Or colors? Do we want to lerp between colors or characters? Maybe we just lerp between colors. So we say this is start color, this is an end color, and this is the time interval with one L. So self the start color equals start color, self dot end color equals end color, and self dot time interval equals time interval. So then we have a method we could call start animation. And also end animation or stop animation. Animation. And this will yes, and then we need another function or method which returns the current color. So we will have something like return animated color. I don't know, something like that. Let's have a look at the chat. Right. So animation that changes the color between two states in a specific time interval. So we basically start the animation and we will switch between colors every time interval. So start color and color, start color and color. And we do that between the start animation, we call start animation, and we call stop animation. And in between we can return the animated color, which we then can use for the snakes to render with. So basically that one. So we kind of need to have a way to set the color priority of the snake, then based on this animation thing. So what we need is the time, and then we say we have to learn between those colors, and we start with a start color. So start animation, we need to have kind of a animated color equals to none. And if you start the animation, we say self yeah, we say something like animated color is equal to self.start color. And we also need to set the time. Yeah. This won't work, right? Because we kind of need oh no, yes, okay. Ooh, yes, I know, okay. We need no, actually we do not, so wait for it. So the whole magic will happen in this method return animated color, where we kind of really will collect the color. We will no, not collect, we will calculate the color. So so we need to set if we start the animation, kind of the time, so of the last color update, basically. So we say last time updated is also none, and if we start the animation, we set the last time updated to time.time. So when we do that, we kind of have the last time updated. And then in return animated color, what we will do is to say how many intervals lie between the current time and the last time updated, which means how often I have to switch the color to get the correct color to return. Yeah. So so if the current time.time is greater or equal to self.last time updated plus, actually not. So this is kind of sufficient. So if time.time is greater than the last time updated, we need to calculate the color. So calculate color change. Let's have a look at the text. Right. So if this time is greater than the last time updated, we calculate the color change, then we update the time. We don't need a comment for that, so we say just last time updated equals to current time. Let's quickly create that variable current time equals time.time, and then we can substitute this with current time, so we actually have the same time here, and then return the animated color. So animated color, return animated color, and we can get rid of that here because we will only compute it in this method. So yeah, how to do that? Basically, we need to get the amount of time intervals that lie between last time updated and the current time. So we can get the time delta, so the time that has passed between last time updated and the current time, because last time updated is really the timestamp, not the duration. So time delta is then just current time minus the last time updated. Yes. And intervals passed now is then equal to time delta divided by the time interval. So this then will get us how much intervals have passed, and we basically could cast it to an integer, doing integer division. And yeah, then kind of decide if it's even or uneven, if you have to change the current color to start or end color. Yeah, something like that. Ooh, yeah. Seems I'm dropping some frames here. Alright. Yeah, so just let us print out the intervals passed. And also do save animated color, start color, save time subs, yes. And then something like bool here, which says if we do the animation or not. So something like is active equals to false, and we state in the start animation method that is active is actually true, and then when we stop the animation, we also set it to false again. And in here, in the return animated color method, we just state if self.isActive, and we do all of that stuff. And otherwise, what we will return will return, I don't know, the star color. Maybe even a runtime warning, because it doesn't make sense to return an animated color if the animation is not animating. Yeah, but then we'll just print out the star color. So, oh yes, and I have to return that. Alright. Yeah, and we don't have the animated color here. Oh, and we do need that. Yeah, I don't know. Let's leave it for now with that. So we created the packing method. Where I want to test that. So we create the animation. Animation equals blink animation. Is it blink or blinking animation? Blinking animation, I would say. So I'm not a native speaker, so I don't know, but it's the state of action, the blinking. So maybe that's what it is. So animation, blinking animation. We need a star color. Yeah, I don't know. Let's call it blue. And this is red. And then we change the color every second. And we start the animation. Animation.start. Then we do some loop while true. And then we print out the state here. So what we will do is we wait some time. Oh no, we call animation.return animated color. Then we do some waiting. Time.sleep of let's say half a second, and then we do the thing all over, and we want to have a way to abort that, so we wrap that in a try except clause and say keyboard interrupts. If that occurs, then we break from the loop. Alright, so did I set that up? No. I actually do not have set up the build system. That is too bad! So Python animations.py. Oh, I forgot the selves. Alright, let's do that again. Oh yeah, right, and I should get rid of the integer division here to let us see what's going on. Okay. Since we set the interval to 1 second and we sleep for half a second, this output here is actually the second we have slept. So So we should also print the color which has been returned. And it's always blue because we didn't change anything. Yeah, that's okay. So if we change the wait time to 2, yes, this is also correct. And if we do now the integer division, which means that 2 full intervals have passed, and otherwise here in this case we only had 0.5 intervals, so we truncate that. It's not a rounding, so integer is not a rounding, it's a flooring operation. So we do not round up 0.5 to 1, but just we cap at the first floating point number at the first position. So it will cap, and then it's just 0. So this is actually what we want, because then we know, oh yeah, we didn't change the state of the animation. Okay, cool. So now we have to think about how to change the animated color, and then it's actually a good thing that I have that as the class member here, because well, we can have access to the last color which we had in the animation, since we updated. Does this make sense? Oh, I guess we're doing badly, but well, yeah, let's just... Well, we're setting our kind of our time origin to the last time we updated, which is totally off the static time interval of the animation, right? But well, this should be an easy fix. Well, just to get the color change, which is independent of that, we say, so if intervals passed, if that is even, I guess I don't need that. Then we do something, and else it's uneven, then we do something else. So basically, if it's 0, 2, 4, and stuff, we do not have to change the color we are currently at, because that's the same color. But if... yes, okay. Then we'd have to do something. If it's uneven, so then we have to change something. So this should give us that the thing is uneven. So 1 and 3. So we basically did we did an animation step. So we're currently advanced by more than an interval step. This means we change the color. So if self.animated color is equal to self.start color, start color. Then we set animated color to end color, and otherwise animated color equals to self.end color. So let's try that. So it's always blue because we are exactly at the interval, and there is nothing that changes. Yes, this is the thing. So if we do it at 1.5, maybe this is not doing what I think it is doing. So we should fire up Python. Yes, and then say if you have an interval difference. Yes. So if we got 4, this is even. This is odd, so this is not equal to 0. This should be even, and this should be odd, and 0 is also even. Yes, so this is doing what it should do. So we say if intervals passed are odd, then we should change the color. So if self-animated color is equal to the start color, we set the animated color to the end color. And if it's not, then we set it to the start color. Yes, alright. So there was book. Okay. So this is hooked up, but I guess it's not the origin, the time origin is not quite right. Yeah. So I see we got some folks in chats. So I can fire up the game. So this is the game. Basically, this is the game window, and you can join by typing exclamation point join, and then you are spawned in with this little snake, which has the character of your the first character of your name as the head, and then some body segments, and then you move around with those commands. And you can collide and eat other players. And it's totally written in Python. Yes. So that is the game. And currently I'm thinking about creating an animation, a blinking animation, which can be used if the player gets hurt. So if he is smashed into a wall or something, we can use this animation to signal to the player, oh, your snake is currently being damaged. And we do this by interpolating between a start and an end color based on the time interval. Yeah, and kind of calculating the color whenever we call the return animation color. So basically, we got this time interval, and then superimposed on that, we got another interval. We we want to return the animated color. And so to make it computationally cheap and don't have a loop here in this class, I just want to return the color and calculate the color whenever I call this method. But this is certainly not the way to go, because the time origin is set to whenever we whenever we kind of last update it. So how to do that? So we say, when we start the animation, we set last time updated to time.time. And then at some point later, we want to return the animated color. And we have the current time, and then we say, well, if current time is greater than last time updated. So yeah, this is actually true for every time. Yeah, this is actually true for every time, so I can get rid of that. And just calculate the color. So we get the time delta, which is the time between the current time and the time we last updated. Then we calculate the intervals which have passed between that. And round that, floor that to an integer. And then based on that, we say if there has no interval passed, then we remain at the color, and otherwise we change the color to the opposite color. And then we set last time updated to the current time. So what if we then enter the next round, say just, I don't know, half the actual time interval. So then this time delta is actually, well, this interval is still being 0. Yeah, this is exactly the problem. So This is the problem. Because yeah, because then my time origin is the last time updated, and it will the time the color then will only change if there is exactly one time interval between the last time and my next call of return animated color, which is not true. Damn it. Damn it. So, to make it quick and dirty, we could store a reference to the start time. So where we basically say self.last time updated and self.start time are equal to time.time. And then I get my time delta, which is the current time minus the last time updated. And we have to add to that start time and then do the time interval thing. I believe so. Self.start time. Oh, did I misspell that? No, start here. I did that. Start time, start time, start time. No. I didn't want to do that. I wanted to test that, so animations. Blue, red, blue, red, blue, red. So, yeah, I'm not really seeing that. So the blinking animation is about 1 second. So maybe we choose that on random. So we say import that. Import a random. So when we say sleep time equals random dot and range, choose a random item from range, start, stop, step. This fixes the problem with red changes endpoint. These are just ints. I don't want an int. I want. What does this give? I guess between 0 and 1 exclusive. Port random dot random. Yes, I guess that's so. And random dot rand range. Yes, between 0 and 1. 2. Yeah, okay, it's only for integers. So we use random range, and then we can lerp that between, I don't know, between 0 and so this is if that thing is 0, then we have this minimum value, and then we want to go to, I don't know, 0.25, so a quarter of a second, and do that basically. and therefore we can just write this. Exactly. So then we do a sleep time. So now we can basically count the 1 seconds. We have something kind of a polling rate is much smaller. Polling interval is much smaller than this 1 second, so we can see if the colors change in a second interval or not. So, oh, what the hell? Maybe let's get rid of those intervals. Yeah, there's certainly something going on because it's switching the color every time we call that. Man, what is going on? So I guess this should give us the sampling. Maybe make it even smaller. Nope. There's my board. So this one. Yeah, so definitely my sampling interval shouldn't affect the animation. So there's something. Yeah, so there's this issue remains. We couldn't solve it with adding just the start time. The issue of the time origin. So yeah, so we start the animation. Wait, is that doing what it should? Save.last time updated and save.start time. It did. Cool. So this is the time we start, and then we request an animation frame. Add the time, current time. Oh wait, maybe yes. Okay. What if we just compare the current time to the start time and don't give a shit about the last time updated, because this is actually what shifts the origin, right? So yes, maybe get rid of that. So last time updated. Sorry. So we could name that to first time updated. No, I don't know. So start time. Current time, time delta is then just current time minus the start time. And then we do the time delta over time interval thing. and this should be it. Let's test that. Blue, red, blue. Oh, interesting. Okay. What is going on? That's kind of funny. So we did start with blue and not none anymore. Oh, that's cool. So blue, and then after 1 second we transition to red, but it's not quite sure that should do that, and then it's blue again. Then it does some crazy transitions and it's blue again. Transition, and then kind of accidentally switches to being red. So why is that? Why is that? So we can disable this printout and do the interval printout once again. So it's 0, then it should be 1, 2, 3, 4, 5, and so on. So this is actually quite good. Why? Yeah, so if we enter the first interval, we execute we need to change the color. Yeah, maybe. Well, we have a check here, so if oh no, it's yes. All right, I see the problem. So yeah, what we just could do is to say last interval. So we store the last interval we were at, and then compare. If we are greater than that, then we change the color. Now that's actually bullshit. Because what if we have an interval that is greater by 2, it should be the same color, but then we would change that. So we don't actually need that either. So we stay with that. So we say if the interval, the interval count, intervals passed, is still odd, then we will change the color. So if self-animated color is equal to the start color. Yeah, so now we thinking is hard. Now we are not relative anymore to the last interval. So what we have here is really the absolute interval count, being if the interval is odd, then we always have the end color. If the interval is even, we always have the start color. So if interval passed, let's do it that way. If the interval that is passed is even, then we can check. No, we actually don't need to do that. We just return. self.start color, and otherwise we return the end color. And this is something we don't need, and this is something we don't need. Yes, and Maybe that does the trick. Okay, I thought this was a very long 0, but that's okay. So this is the intervals passed, and then we get the color here, and we should print that in order to verify that, as we have done for the intervals. Red, blue, red, blue, red, and blue. Beautiful, but it shouldn't be red, right? It should start with the blue one. That's a bummer. Why is that so? Animated color, start color. We don't actually need that. We just have to state when we do the start. When we do the start of the animation, setting the whole thing to active. Yes, and then if intervals pass is 0, then we return the start color. Otherwise, we return the end color. So why is that red? Because we have checked the modulo of 0 is 0. Yeah, this is... yeah, I'm not sure. Not sure about that. So yeah, let us save that for now. So git status, git add animations, git commit, adding animation, blinking animation, stop. Oh, I misspelled that. So we do git commit amend. Animation. I really don't know how to operate Vim. Animation. Dear Lord. Animation. Okay. Need to Google that. Insert text Vim. No, not. Damn it. Yes. I need to change the mode. Append text following current cursor, append text to the end, insert text before the current cursor position. So, animation. Oh, great. Alright, and then we do a write and quit, adding blinking animation stub. Right, so this should be it. Now we hopefully corrected that commit statement. And we have, so adding blinking animation stub, which is where currently our master is. Alright. So we can push that. Push. And then we could, yes, we need to somehow hook that up to the color thing when we have a collision. So, but this is something we can do in the next stream. So, take care, and to the next stream. Bye bye.